Before we get started in this video, I want to point out that the length of the video is not a mistake. I set out to explain CC Particle Systems 2 and CC Particle World, thinking that it would take me around 30 minutes at the most, and here we are with over an hour-long video. If you don't have that much time to watch all of this in one setting, that's okay. I've actually created a bunch of YouTube shorts that explain all the features of CC Particle World in much more bite-sized lengths. So you can check that playlist out in the description of this video if you want, or you could use the chapters of this video to watch little parts of it at a time. I would suggest that you watch it in order though, at least for the first time. And one last thing, this is exactly how I teach my Skillshare classes. I start recording and it takes as long as it takes to explain what I want to explain. I don't like leaving anything out, and all these little details I think are important to understand how everything works in After Effects. So you're basically getting a Skillshare class for free in this YouTube video. And if this video makes you more interested in checking out my Skillshare profile, you can find it in the description of this video. All right, let's get into this. CC Particle Systems 2 and CC Particle World are both found under the simulation category. And these effects are both particle emitters, which is an extremely powerful thing for motion graphics. Both of these effects are made by Sitecore Effects, so a lot of the controls overlap. And if you've watched the CC Mr. Mercury video, many of the same properties and controls also carry over from it. These two effects are just much more advanced and give much more options than CC Mr. Mercury. Now, the main difference between CC Particle Systems 2 and CC Particle World is that Particle Systems 2 is a 2D particle emitter and Particle World is a 3D particle emitter. And not in the sense that the particles are actually 3D, but that they work in 3D space. Not just the X and Y axis, but also Z space, and they react to 3D cameras in After Effects. But we're going to start with CC Particle Systems 2 and then see how CC Particle World is a little bit different. I need to start by making a solid. So I'm going to go up to Layer, New, Solid, and I'll name this Particles. I also want to make sure that's my comp size so it fills the whole thing and click OK. Then I'll drag out CC Particle Systems 2 onto that layer. Immediately, if I play back, we're going to see this explosion of lines. Each one of these lines is referred to as a particle. It almost looks like a sparkler, which is pretty cool considering we haven't done anything yet. Now, I'm gonna make this a little bit easier to look at by changing the color of my background to black. I'm just gonna add a fill effect to it and turn it all the way down to black so we can focus on that particle emitter very clearly. Now let's take a look at the structure and layout of the controls. Up at the top, we have a birth rate, which is basically how many particles are being emitted. We have longevity measured in seconds, so how long each particle lasts on screen before disappearing. Then we have a producer section, which is where the particles are being produced from or emitted from. We have physics, which is full of controls for how these particles are actually reacting to gravity and other physics. We have a particle section, which is where we style the actual particles that are coming out of the emitter. And then we have a random seed, which just randomizes the entire simulation. Now let's walk through each one of these options, forgetting about what the actual particles look like in any of the physics, anything like that. We'll just start with the birth rate. If I turn this value way down, so like 0.2 or 0.3, then the particles are going to come out at a much slower rate. And if I increase that, obviously we're going to go in the opposite direction and get a lot more particles. But as you'll notice, this is rendering very quickly. Most particle generators are fantastic at producing and rendering thousands, if not tens of thousands of particles on screen every single frame. I'm going to change that back down to 4 just so we're back at our defaults, and we'll look at the next option, which is longevity. If I turn this value down, then the particles are just going to last less. So if I move it down to 0.1, then it really does look more like a sparkler, where it's bright right at the start, but it decays very quickly. Maybe I turn up the birth rate a little bit and that gets to be much more dense, or I turn it down and it gets to be nowhere near as dense. Or I could turn the longevity up way past 2 seconds and then they're going to last much longer than they're on screen for. So they fall off the screen before they ever disappear. But if I dial this back again to have a shorter longevity and I pause it right around here, you can see that the colors are actually changing. It's more of a bright yellow in the center and darker around the outside edges. And that has to do with how the particle is styled, but we'll get to that in a little bit. Next up is the producer, and this is where the particles are being emitted from. So let's open up that section and take a look at the controls. It's pretty simple. We just have a position point control. If I click and drag this value around, it moves that producer point around in my comp, and I can even click and drag to move that around. So now my particles are going to be emitted from the top right corner or the left side, wherever I put that producer. And I could even keyframe this property. So if I set a keyframe here at the start of the animation and I go forward maybe a second and move it down here, and then I go forward another second and I move it up here, you can see that the particles are actually trailing off because they're being emitted from wherever that producer is at that point in time. It's not sticking with that producer, it's just being emitted from that producer at that particular point. So if I press U to bring up my keyframes and I ease this with the F9 key, go into my graph editor, and then just increase these speed handles a lot so that there's a lot of fast movement right in between the keyframes, and it gradually gets there, then we're going to see a much more dynamic looking particle simulation. The other two options we have under the producer are the size for the radius X and radius Y. So currently it's just 3 by 3, so it's pretty much a small little dot. But I could increase this radius on the X and Y axis, and now it's a much bigger producer. And maybe I want to turn up the birth rate so I see more particles, or I could turn the birth rate down and the longevity up to see them longer. And we have this massive spot moving around that's emitting all these particles. I could also go all the way down to 0 by 0, and then it's just going to be an infinitely small dot, a specific point emitting all these particles. All right, next up is the physics. And this is where we can control things like how the particles are actually being emitted. That's what this animation property is for. It's all of these different animation types for how the particles are being emitted, and it's defaulted to explosive. Before we explore any of these other options, let's just go through the other physics controls. First of all, we have velocity, and this is how quickly the particles are actually being emitted from the producer. So if I turn it all the way down to, let's say, 0, then they're not going to be emitted with any velocity. They're just going to drop, basically, and react to physics, which, as you can see, actually creates a pretty cool look, especially with a high birth rate. If I were to turn this down quite a bit, then it's going to get much less solid. But keeping that birth rate up makes this very cool solid shape that's very dynamic, almost like a tapered stroke, and creates a very unique, flowing looking simulation, almost like sand or a ribbon is being dropped out from that point. And using some very basic expressions, you could tie this point to a null object. So if I go up to Layer, New, Null Object, and I'll call this Emitter, then I'll copy and paste these keyframes onto that null object, and then add a simple expression by Alt-Option clicking on the position property and just using the expression pick whip to select the emitter layer, then type .toComp, press enter for that autofill, and between these parentheses, do an open square bracket, 0, 0, 0. What this will do will map the position of the producer to the emitter null wherever it is, regardless of if it's parented to something else, it will always find where that null object is. Now, when I copied and pasted that position property, it actually duplicated CC Particle Systems 2, and I didn't catch that. What I want to do is copy this position property and then open up the position property for that null object, select it, and paste there. Now that same movement is transferred to this null object. I'll get rid of that CC Particle Systems effect, and then I can actually take the keyframes off of the original particle emitter because they're now following the null object. The benefit of doing it this way is this can be parented to any layer, but I also now have a motion path that I can modify. So if I just switch to my pen tool, I can make this much more dynamic rather than just linear movement, the way that point controls are forcing you to animate. So if I play this back, now it's going to be much more smooth, and I can animate that particle emitter just like any other layer. All right, let's go back to the physics of this emitter and turn the velocity back up. In fact, let me reset it to the default, which is 1. And with this explosive animation type, we already know what that looks like. But if I increase this velocity to, say, 5, then this is going to be a much more violent explosion, and it's going to fill the entire comp. So maybe I want to turn the longevity down to dial that back. And what's basically happening is that my particles are now streaking out longer, but disappearing much quicker. I could also turn that birth rate down so it's not quite so crazy. But this is how you can play with the interaction between the physics and the birth rate. Let me reset these back down to defaults, including the velocity. And the next option is inherent velocity. And to see this a little bit more clearly, I'm going to turn the velocity down a bit. Now, the way that this particle system is moving around is going to be affected by this inherent velocity. It's currently set to 0, but if I increase this value, what's going to happen is the movement of this point control is going to influence the velocity of all of the particles. So I moved this into a positive direction. So let's play this back and see what happens. You see how those particles now look like they're being thrown around by the producer? they're moving in the direction that the producer is moving. And I can increase this up to 100% and it will be much more influenced by that movement. I could even increase that past 100% and just have these particles really flailing around and going really crazy every time this point control moves around. But what's interesting is that I could even put this in a negative direction. So if I put this down to say -60 or somewhere around there, then the particles are going to fly off in the opposite direction, almost like they're propelling the point around rather than being thrown around by that producer. So if I really crank that back and I turn the longevity down, then it almost looks like fire or sparks being flown out of a rocket, propelling it around. It's a very cool effect. And I'm sure by now you can see just why a particle emitter is so powerful. With all of these controls, you can create very cool looking simulations. And this is all built right into After Effects. Let's turn that inherent velocity back up to say 40%, and then turn the gravity down to 0. I'll also turn the velocity all the way down to 0. So now the only movement from the particles is coming from the motion of that producer. And now we're getting this kind of ribbon flowing around, sparking out and reacting to the movement. It's very organic and very fluid. I'll undo to get back to our velocity and gravity settings so we have these sparks flying around basically. And the next option is gravity. Now I've already turned this all the way down, but I could increase this to make it look like these particles are much heavier and they fall faster. Or I could turn the gravity way down, maybe not all the way to 0, but maybe 0.2, and they're not gonna fall quite as fast. But because this is a simulation, I could even do negative gravity, and then they're going to fly upwards, and it'll be floating up more like smoke or flames rather than falling down like sparks. I'll set that back to its default at 1, and then the next option is resistance. And if I increase this value, it's basically going to pull back the velocity of those particles. So initially, they'll be emitted at whatever velocity we set this to. So let's change it up to say 2, so it's pretty explosive. But if I really crank this resistance up, you see how it's pulling all those particles back. So they're exploding out, but then very quickly slowing down. They're being influenced by that resistance so that they don't travel nearly as far. Maybe I'll turn up the longevity a little bit so that we can continue to see those particles fall to the ground. But you see that that velocity is really dampened when we increase that resistance. I'll set that back down to 0. And the next option is direction. So I'm gonna turn my velocity back down to say 1 and the longevity back down to 0.7. And the direction for this explosive animation, at least, is basically how it is rotated, how that producer point is rotated. So if I increased my radius to say 3 by 3, or maybe 10 by 10, so we can really see that shape, and then I change that direction, you can see how it's just rotating it around. So you could keyframe this, animate it however you want, but that is what the direction property is doing. Next up is extra, and if I change this value, it is not affecting anything. And that's because this value is specific to certain types of animation styles. But because there are so many of these, we're gonna get to that in a little bit. First, I wanna finish off these controls and move on to the particle section. Like I said before, this is where we style the particles and control how they actually look. Our particles look the way they do right now because of the particle type. It's currently set to line, but we have lots of options in this menu for how these particles look. The next option is star, and if I change it to that, our particle system looks completely different. Everything about it that we've set up prior to this still applies, but because we changed the particle shape, the emitter looks completely different. Actually, I'm gonna change my producer back down to say 1 by 1. Just so we have a point emitting all these particles. And you might have noticed that as soon as I switched the particle type, we had a couple more controls show up. So not all of these controls are available for every type of particle. But for star, we have birth size and death size. So these are basically the in and out points of every particle, and it controls how large the particles are at those points. So at the birth, at the very start, we can see these particles birthing, basically being created and emitted from this producer. If I turn the birth size down, they're gonna get much smaller at the start. Currently, I have the longevity set to 0.7 seconds. So if I go to around this point here, we can see those particles that were initially emitted are fading out and disappearing at that point. This is basically the death state of these particles. And if I increase the death size, they're going to get much larger before dying or fading out. Or I could turn that down and keep them much smaller. So let's say that I want these to be really tiny little specks, more like fairy dust. And there we go. We've got the particles shooting out. Maybe I want to mess with the physics, increase the resistance a little bit, crank up the inherent velocity, maybe even turn the velocity all the way down, or not quite all the way down. And it looks like we have some fairy dust. Maybe the gravity should be going in the opposite direction so that it's kind of floating upwards, but that inherent velocity is still shooting them in whatever direction the emitter is moving. All right, let's jump back to the particle settings, and the next option is size variation. So this is basically size randomness. It's set to 50%, but if I increase this, then we're gonna have much more variation in size between each particle, or I could turn it all the way down to 0 and every single particle will be exactly the same size throughout the whole simulation. I'll leave that at its default for now. The next property is opacity map, and this is what controls how transparent or opaque every particle is. It's set to fade out, which means it's going to start at whatever we have the next property set to, which is max opacity, and then gradually fade out to full transparency. Now I could increase that max opacity so that we have 100%, or I could turn that down so it's not quite as visible, but nothing will ever be more opaque than this max opacity setting. I'll undo back to its default and we'll take a look at the other opacity map options. We have fade in, which is just going to reverse the opacity, so they start transparent and then fade in. That's just a different look. We have fade in and out, so the particles will start transparent and they will end transparent. We have constant, where there is no fading whatsoever. The particles just appear and then they disappear. We have fade out sharp, which if I get to a frame where we can see that trail just fading off and we change it from fade out to fade out sharp, you can see that that's basically just decreasing the decay of that opacity. So it fades out much more quickly near the end rather than more gradually on the fade out. And the last option is oscillate. And this is good for making basically twinkling stars. It's oscillating that opacity from fully transparent to fully opaque, and it's making all these stars look much more twinkly. The next option is source alpha inheritance, and this is affected by the layer that we've applied CC particle systems to. Since I used a solid, it is 100% opaque. There are no transparent pixels whatsoever in it. So checking this box on will not do anything. But if I turn this effect off for a second and add another effect like Venetian blinds and apply that before CC particle systems 2, I'll set the transition completion up to 50% and change the width to be much wider. So now I have these black and white bars basically, but if I turn off my background so you can see through to the transparency grid, those black bars are actually transparent. So let's turn that background back on, turn CC particle systems back on, and now wherever there are transparent pixels, prior to this effect being applied, the particles will inherit that transparency. It's based on the opacity of the layer. So as it crosses right here, if I turn the effect off, remember, white is where there are solid pixels, black is where there are transparent pixels. The particles are only going to be visible when that producer is over visible pixels. Now, if I were to do something less drastic, and instead of making certain areas completely transparent, instead I use maybe a turbulent noise to generate this texture, and then maybe an extract effect right after that, and make those black areas transparent and soften it out a little bit. So now we have semi-transparent pixels as well as opaque pixels. I'll just increase the scale of that turbulent noise so it's a little bit more drastic, and then turn CC Particle Systems 2 back on. And now those particles' transparencies are going to be more or less depending on how transparent the pixels were from the turbulent noise in the extract that we applied before it. Now, I'll be honest, I've never really used that property, but it is worth knowing that it's there, and it does give you a lot of control on how these particles are actually being emitted. Let's reset some of these settings. I'm going to change this back down to fade out, reset the birth size and the death size, uncheck source alpha inheritance, and next we'll look at the color map. So this is how these particles are being colored, and it's currently set to birth to death, meaning we have a birth color and then it interpolates into the death color over time. So I could change the birth color from yellow to say white, and the death color to something more like this tealish cyan color. And now we've kind of got a gradient going on from the birth to the death. But that's not the only way that we can color these particles. We can change this color map to one of three other options. So instead of birth to death, we could say origin to death. And what that means is the origin color of the layer. And if you remember, before I applied this effect, it was a white solid. So it actually didn't change anything. But if I were to add a fill effect prior to this and changed it to any other color, then it's going to pull that color as the origin color and then interpolate to the death color. Now, if I were to apply this to a more colorful source like this photo right here, I'll just copy and paste CC Particle Systems 2 from that solid to the actual photo. then my origin is going to be very different, because remember that origin point is wherever the producer is over top of the source layer. So it's going to sample the color underneath that point control and apply it to the color of the particles. So with origin to depth selected, if I go to the start of my animation and look at what pixel it's over top of, we're in this orangey red section of these smoke plumes. So it's going to sample red right there. And as it moves across the screen, it changes colors: yellow, green, blue, and so on. Now we could change this from origin to depth to, say, birth to origin, and it's basically going to reverse that. So the particles will eventually get to whatever color was sampled at their initial emission. Or we could change that color map to be origin constant, where we don't use the birth or death colors at all, and it's just going to color those particles based on the sample underneath. And this doesn't have to be a static image. It could be a video or an animated gradient or anything like that to give very custom color maps to all of your particles. All right, I'm gonna go ahead and delete that layer and bring my solid particles back and turn off that fill and change this back to birth to death. The next option we have is the transfer mode, and it's set to composite, meaning if I solo this layer, those particles are just stacked on top of each other. There's no blending involved. But if I change this transfer mode to, say, screen, then those particles are going to blend into each other. And if I change this burst color to be something much more vibrant, you can really see how these are now blending into each other, just like the blend modes for layers. So screen is going to make it look much brighter. I could also change this to add to make it even brighter than that. And now it looks much more hot. It looks like an actual fiery source, which could be very useful for making fire. So if I make the center of my core this kind of bright yellow color, and I make the death color a darker red color, then we're going to get something that looks a lot more like flames. All right, now that we looked at all of the particle settings, we need to go through the rest of the particle types. So far, we've only looked at line and star, and you can see that those are divided by a little line, and we see that in a couple of places. This is basically organizing the different types of particles. Line and star have very similar controls, and we can't do much to them. The line can't get any longer or thicker, and we can't really do anything to the star other than change the size. Like we can't change the rotation or the shape of that star at all. But the next category is full of spheres. So the first option is shaded sphere. And I'm going to change my transfer mode back to composite just so there's no blending involved. And I'll zoom in nice and close here. You can see that this looks very bubbly. We basically have an opaque sphere that is shaded around the outside, so it gets darker around the edges. If I play this back, you can see how that kind of looks like underwater bubbles. But when the emitter's not moving, it almost looks a little bit like smoke. So if I change that composite mode to, say, screen, then we're going to get rid of that shading basically, because it's eliminating the darker pixels, and it does look a lot puffier or cloudier. And increasing the saturation of that red may be making it a little bit more orange, and increasing the saturation of the yellow as well could really make this feel a lot more like flames. All right, I'm going to change that back to composite, and we'll take a look at the next option, which is faded sphere. This is very similar. If I zoom in nice and close again so we can see those particles, I'll compare this from faded sphere to shaded sphere. They're basically the same, but instead of darkening out the outside edges, it's fading those edges out and making it much softer and feels a lot more like smoke. Again, changing that to screen or add is going to help those particles blend together a lot more, and we could make something that looks a lot more convincingly like smoke if we just change these colors a little bit. Maybe add just a slight amount of blue in there, or maybe yellow, just so it's not purely grayscale. And if we increased that birth rate and maybe turn up the resistance, turn that inherent velocity, and dial back the gravity a little bit, then it really will start to look a lot more like smoke. And it might actually be a good idea to turn that resistance all the way down, or at least a much lower value. We could also increase the birth size to fill in some of those gaps and increase the depth size as well. And that's starting to look a lot more like an actual plume of smoke. All right, let me undo back to where we could see the details of that particle. And we'll take a look at the next shape, which is shaded and faded sphere. So this is basically combining the two. I'll change this blend mode back to composite. You can see the difference between shaded sphere, faded sphere, and shaded and faded sphere. It's basically bringing in some of those dark pixels and will change how the particles blend together, especially when you're changing the blend mode. Next up is bubble, and this is kind of the opposite of a shaded sphere, where instead of having the center of the particle being opaque and the outside edge is transparent, the center is transparent and the outside is opaque. So let me turn that birth rate down so we can see those a little bit more clearly, and then change this from bubble to shaded sphere. So you can see that it's basically the opposite. Now, if we play this back, it kind of does look like bubbles are being emitted kind of underwater. If I turn that inherent velocity down to maybe 10 and change these colors to look more like they're underwater, then we can really generate something that looks like it's emitting air bubbles. And if I turn back that gravity, it'll look like they're floating away even more quickly. All right, those are all of the sphere types of particles. Next up are the polygon types. So the first one is called motion polygon. And if I zoom in here nice and close and play this back, you can see that these are basically made up of triangles. And I'm going to increase the inherent velocity up to around 60 and turn the gravity down to 0 as well as the resistance down to 0. What's special about these particles is that they change shape and scale based on the motion of the producer. So at the beginning, where the null isn't moving, those particles are very small. They're just small triangles. But as it moves along and picks up speed, not only are they scaling up, but they're also pointing in the direction of the velocity. So if I turn that inherent velocity to a negative number, since those particles are now being emitted in the opposite direction, the points are going in the opposite direction. So that's why it's called a motion polygon, because it follows the motion of the producer. And I could also increase the birth and death size. And as you'll notice, that is a little bit unique to this effect because it's just scaling up the width, basically. It's not increasing the length at all. All right, I'll set that back to its default and we'll take a look at the next option, which is tri-polygon. Or a simpler way to say that is just a triangle. I'm going to increase the longevity a little bit so we can see that longer and play this back. See that this is just emitting triangles and they're kind of rotating and floating out in kind of a random way. Now these particles are a little bit unique because if we go back up to the physics category and look at the direction, this property is actually the speed of rotation for this particular type of particle. So if I change this down to 0, then the particles aren't going to rotate at all. They just scale up and move around based on the velocity and inherent velocity properties. But if I change that direction up to 1 or 2, or the higher I go, they're going to rotate faster and faster. I'll set that back down to 1 and we'll take a look at the next option, which is quad polygon. Another way to say that is square. They're squares or diamond shapes instead of triangles, and that direction control does the exact same thing. It controls how quickly those particles are rotating. Set it down to 0 if you don't want any rotation, or increase it if you want them to rotate. The next type is cube, and this is actually a 3D shaded cube. If I zoom in here, you can see each individual one of those cubes. Again, rotation is based on that direction property. I think you'd have to have a very specific use case to want 3D cubes as your particles, but it is cool that we have that option. Next up is tetrahedron, which is basically pyramids, 3D triangles. I zoom in nice and close, we can see those. Again, direction will control the rotation speed. And then next up, we have textured tri-polygon. So we're going back to just triangles, but we can actually texture these triangles. But once again, it's based on the source layer that we've applied the effect to, just like the origin color. So I'm going to bring that photo back out, and I will copy and paste that effect one more time to it, turn off my solid version, and immediately we can see those colors being transferred to our particles. Now, this photo was pretty abstract, but if I zoom in here nice and close, you actually can see texture on those polygons. You see how there's a darker spot here and a brighter spot right there. This would be even more apparent if I go into my particle and I change the opacity map to, say, constant and the max opacity to 100%. The actual texture of the photo is coming through on those particles. The next particle type is textured quad polygon, which is exactly the same, except they're squares instead of triangles. All right, I'll shut that off and turn our solid version back on, and we'll look at the next set of particle types, which are lenses. So if I change this to lens convex, then we're going to basically get flat circles. But this is again because of the source that we've applied the effect to. Since it was just a white solid, it appears like they're just flat 2D circles. But if I turn my photo back on and I change that particle type to lens convex, then it is actually manipulating the pixels of whatever is beneath it with the lens convex warping. So it's a very interesting look. And maybe I want to change that opacity map back to fade out, just so it's not so abrupt when they do disappear. The next option is lens concave, which is going to just change the warping. If I back up to a more clear state where we can see those particles and how they're affecting the pixels, I'll just change that to lens convex and undo, redo. So it's just a different distortion. Next, we have lens fade, which fades out the edges and uses the lens distortion. We have lens darken fade, which just makes them a little bit darker, as well as lens bubble, which is similar to the bubble sphere type, but it's applying that lens distortion in addition and sampling the source layer as it does it. All right, those are all of the particle types. The last thing we need to look at is the animation type, because this whole time we've only been using the explosive animation, but we have lots more options. So I'm going to shut off this photo. We'll go back to our solid version, and I'm going to change that particle type back to line just for simplicity. So let's play this animation and see how it looks one more time. So when it's static right here at the end, remember the explosive type kind of looks like a sparkler. But if we change it to the next option, which is Fractal Explosive, there's a slight change, but the animation overall looks pretty similar. The difference is that it's less uniform than explosive. And the direction property actually changes this a bit more. So if I increase this, it's going to change how the fractal influences the explosion. Whereas with the explosives, it basically just rotates the producer. So this gives a more uneven look and something that may work a little bit better for fire. So if I turn that gravity in a negative direction and we change this to be a fiery color scheme again, I'll go to something yellowy and then really nice saturated red, and then change our particle type to say shaded sphere and change the transfer mode to add. Then I'll just increase the birth rate so we have a lot more particles, turn down the longevity so they don't last quite as long, and maybe mess with those colors a little bit because they are pretty cartoony at this point. If I back off the saturation and dial that back just a little bit, then we're going to get something that looks a lot more hot. Maybe don't need quite as many particles. Turn the inherent velocity all the way down, maybe increase the standard uniform velocity, and have it last just a little bit longer. Now we've got something that looks a little bit more like a ball of fire. And it has more variation than the explosive animation. If I turn that between explosive and fractal and mess with that direction, you can see how it's making it more uneven. All right, the next animation type is Twirl. And just to make this easier to see, I'm going to change the particle type back to line. Now I have a lot of particles coming out, but you can see very clearly that these particles are literally twirling around, and the lines are actually bending to that shape, to that twirling shape. So if I turn down to birth rate so we can see that a little bit more clearly and play this back, it's very clear to see that animation type. Now, if I were to turn my gravity all the way down, then it's all just going to be twirling around that producer point, which almost gives it a kind of swirling galaxy or black hole type of look. Now with this animation type, the direction is controlling the speed of that twirling. So if I turn it down to 0, we're not going to get any twirl at all. And if I back it up to a negative number, then it's going to twirl in the opposite direction. So that's how you can control the amount of spiraling, basically. And if I increase this velocity to make it a much larger shape and increase the resistance, this is not only going to bring those particles back in, but it's going to slow down the rotation the further out from the producer that the particles travel. So it's spinning very quickly at the start and slower around the outside. The extra property for this particular animation type controls how tight or loose that spiral is. So if I go in a negative direction, it's really going to crank up how much those particles are twirling around. Or if I go out into a larger number, you see that that straightens out the lines quite a bit. All right, I'm going to set these back down to their defaults, and we'll take a look at the next animation type, which is Twirly. And it is kind of funny that there's only one letter difference between Twirl and Twirly, but they do have different looks. Instead of being pretty uniform and kind of like a whirlpool, the rotation for these particles is much more random. It actually looks pretty similar to the explosive type, but if I increase this direction number, you can see that it actually is twirling around. And again, that resistance is going to control how much those lines slow down as they move away from the producer. And just like Twirl, the extra value will control how extreme that twirling is. A larger number will straighten them out, and a lower or even negative number will really pull them around. The next option is Vortex, and this one actually needs some gravity, and it's currently set to 0, but if I increase this, it doesn't actually make the particles fall, it spreads them out. It increases the size of that vortex. So this could be useful for creating something like a tornado. Again, if we change the particle type to be something like the shaded sphere, and we change these to be more grayish colors, then we're going to get something that looks a lot more like dust or smoke. I could increase the birth rate, maybe just change that transfer mode to screen so it doesn't look as hot. And then I'm gonna add one more keyframe right down here at the bottom of the frame so that we can see this a little more clearly. And as our emitter is at rest, I'll just set some in and out points for preview range. We can see that vortex spinning around. So if we go back to the physics, velocity is what controls the height of the vortex, and the gravity is what controls the width. So maybe I want to put that around here. And just like the ones before it, direction controls the rotation speed. So if I turn this to 0, we're not going to get any twirling around, just these particles being emitted from the base up. Maybe that's a little bit too bright. I'm going to darken that, add in a little bit of blue, and click OK. The extra property does nothing for the vortex, but the resistance does bring those particles down. So if I increase that velocity and keep that resistance up high, then it's going to be a tighter vortex. Now I do want this to spin around, so I'll set my direction to maybe 3. And let's see what happens if we just change the particle type to say motion polygon and maybe increase the depth size so that they're a little bit wider. Same thing for the birth size. Turn that resistance down, the velocity down, and maybe the gravity up, and maybe increase the birth rate to say 30. Then let's play this back with the keyframes of the animated null, and we've created a pretty reactive looking tornado. So that's the vortex animation type. Next up is fire. So why don't we change our colors to something that is a little bit more like fire one more time. Nice and bright at the core, and then fiery red at the death point. And using those motion polygons, we've already got something that looks like flames. This is very cool. If you combine this with a couple of blurs, maybe a vector blur, we can make these particles meld into each other a little bit more, and it would feel a little bit more like flames. Now I have the direction set to 3, so this is moving very quickly, but I can move this down to 1, and then it won't be so dramatic. Just like Vortex, the gravity affects the actual height of these particles, how far they travel, and the extra value controls the width. Now this effect would probably benefit from changing the transfer mode to say add, and then I'll change the colors a little bit. Maybe that's a little too yellow in the center. So I'll actually just make that really red, because with that add blend mode, it's going to make the center pure white basically. And then let's go ahead and add that vector blur on top, turn up the amount, increase the angle offset just a slight amount, and then maybe add a glow effect on top of all of that. Increase that glow radius so it's nice and wide, turn up the glow threshold a bit, and turn the intensity down. And very quickly we've created a much more realistic looking flame. Obviously there's a lot more we could do to this, but this is a great starting point. Okay, I'll get rid of that glow and vector blur, and we'll take a look at the next section, which is direction and direction normalized. So let's start with direction and play that back. All right, so what's happening here is that these particles are being emitted out in a specific direction, and then the physics are taking over. So let's change the gravity just to 1, down to its default, turn the resistance all the way to default, as well as the velocity, so this isn't so extreme. And we'll just preview again this static point where the emitter isn't moving around. And we can change that direction using the direction control. So this is just like rotating it around a clock. I can customize where those particles are being sent out. And the spread of these particles is controlled by the extra value. So if I turn this down towards 0, then it's going to be a much narrower spout basically. And let's play this back with the actual animation. So because my inherent velocity is turned all the way down, it's always going to be emitting out at that angle. And I could keyframe this and I can change it to whatever I want. If I want it to go straight up, then it will always be going straight up. If I want it to be wider, I'll just increase that extra direction. The difference between this type and direction normalized is that direction normalized is much more uniform. In fact, every particle is spread out evenly from the emitter, whereas direction is much more random. You can see how those particles are coming out at different velocities and angles. Direction normalized is going to shoot everything out consistently based on that extra fan control, basically. So if I want these to shoot out further, I'll just increase the velocity and compare that to direction. You see how some of those particles are not getting shot out as much, whereas direction normalized is going to shoot every particle out consistently. The last option for animation is jet sideways. So I'm going to set my direction back down to its default, the velocity down to its default, and turn the gravity off, as well as the extra to its default of 1. And we'll take a look at this point where no motion is happening on that producer, and it again just looks like explosive. But it's very different if we play it back during the animation. What's happening here is that particles are being emitted outwards at a 90-degree angle in either direction in relationship to the motion of the producer. So as it moves down, those particles are moving left and right. And as it's moving to the right, the particles get shot up and down. But because we've combined this with the motion polygon, the particles are not only shooting out further at the faster motion, they're also increasing in scale, which creates a very cool looking effect. If I were to change this to, say, try polygon, we're not going to get the same effect because those polygons are not affected by the motion. But motion polygon increases in size. And because we have so many of them, and they're being blended on top of each other using the add transfer mode, we have these fiery colors. It creates something very unique and very dynamic. And we can shape this a little bit with the extra control. This basically introduces more or less randomness. So if I turn this all the way down to 0, we will have no randomness in the direction and it looks much more uniform. If I increase that value, then we're going to get a lot more randomness and it won't be quite as directional. Now my particles are really big here, but if I turn these down and maybe increase the birth rate, then we'll get something that looks a little bit different. But with that, we have covered every single animation type and every particle type in CC Particle Systems 2. And hopefully in that overview, you can see just how crazy powerful this is. But remember at the beginning of this video, I said that CC Particle Systems 2 hardly ever makes it into my workflow, and that's because it is a 2D particle emitter. It only works with this 2D point control on the X and Y axis. And that's where CC Particle World comes in. So I'm going to jump over to a separate comp here, and we're going to again make a new solid layer, new solid, type in particles, click OK, and then search for particle world, CC particle world. Drag that out onto the solid, and this is laid out almost identically. If I bring out CC Particle Systems 2 just for comparison, the first option is different for CC Particle World. We have grids and guides, but if we ignore that for a second, we have birth rate, longevity, producer, physics, particle, and then finally extras. So grids and guides and extras are the only two additions to CC Particle World. But if I open up, say, the particle and take a look at the controls, almost everything is identical. We do have more controls and we will get to those, but basically everything about CC Particle Systems 2 that we just learned will carry over into CC Particle World. So let me turn that off, and again, we'll get to a black background by adding a fill, changing that to black, and then let's take a look at CC Particle World. Again, by default, this is just a big explosion of particles. If I select the effect, click and drag at that point control, it's going to move it around the screen just like before, but we have these guides showing up, and it's giving us this kind of floor plane grid. So let's start there with the grids and guides option. In my own workflow, the first thing I always do with CC Particle World is disable every single one of these checkboxes because I personally do not need any grids or guides to tell me what's going on. It's purely a visual aid, but I feel like I owe it to you to actually explain what they do. So let's start by just turning on the position guide. If I zoom in nice and close, it's this point right in the middle, just this tiny little X, just a guide telling me where my producer is on screen. Next is the radius. So this is the radius of the emitter. If I go into that producer and turn up the radius X and Y, it makes that guide larger. I'll undo that. Next is the motion path. And this only shows up if the producer is actually animated. So I'm going to add some keyframes on the X and Y properties. And you'll notice that these are separated out. So we can't link them up the exact same way as we did with CC Particle Systems 2 to that null object. But we'll get to that in a little bit. I'll move forward maybe a second in time and then adjust this producer, and immediately we can see that motion path, which is represented by that green line. And if I press U to bring up these keyframes, easy ease them, and then give them different, switch to my value graph and then give them both different easings, then we're going to see a curve take shape with that motion path. This is purely a guide though. I cannot click and drag on it to manipulate it whatsoever. We can choose how many frames the motion path is actually displaying. So if I want to see less of that motion path, I could turn that down to say 10 frames or leave it at its default. Next is the grid, and I've completely disabled it, but if I check that on and back this up, you can see that the grid is moving around with the producer. So the grid position is set to floor, but I could change that to producer and it will align it to that producer rather than the floor. We'll get to what the floor is in a little bit. Or I could change this to world and then it will not move around with the emitter. Now this little icon right here next to the CC Particle World title is letting me know that this is a 3D reactive effect, meaning I could make a new camera, click OK, and then rotate my camera around and you'll notice that the effect is actually reacting to it. So if I go back to CC Particle World, that grid is now displayed at a different angle. So let's just add some keyframes on the position of my camera. I'll press P to bring up that property and set a keyframe and move forward maybe 2 seconds and just reposition the camera. Now if I select CC Particle World so I can see that grid and move through my camera animation, that grid is moving with it. And this is why I always choose CC Particle World over CC Particle Systems 2, because having that Z depth and the reaction to actual 3D opens up so many more possibilities. Moving along, we have grid subdivisions, which just controls how many squares are in that grid, as well as the grid size. So I could make that larger if I needed to, or scale it down if I don't. And finally, we have the horizon and axis box guides. So the axis box shows up in the top left corner, and again, is just a guide to show you the orientation of the camera in relationship to the world. So if I change this angle down, bring up that effect again, now we're traveling from above the floor plane to below it. You can see the axis box moving with it. And at this point, you can also see that horizon line. Now, all of these things are great for visual guides. They can be useful for things like the radius of the emitter, to interactively click and drag within the comp window to change that, but it's never been easier for me to do it that way than to actually type in the radius values right here. In most cases, all of these guides just get in the way, which is why I immediately start by just unchecking all of them. That way I'm left with the final render of just the particles. All right, I'm gonna get rid of my camera move and let's talk about how to link up the producer to a null object the same way that we did in CC Particle Systems 2, except this time we'll be using a 3D null object. So I'll start by just copying and pasting that emitter null from the other comp into this comp and then turn on the 3D layer switch. So it's still only animating on the X and Y axis, but I have the option to now add in some Z position values. I'm gonna get rid of the keyframes that I have on the X and Y position for the particle emitter. Now this process of linking the producer to the null object is much more complicated, and it's simply because this effect is not using the same positioning system that After Effects is for 3D space. This emitter's position exists in 3D space in relationship to the world space of After Effects. So if I set this to 960 by 540, it's right in the center of the comp because the origin of my comp is in the top left corner. This is a position value of 0, 0, 0. If I go 960 pixels right or positively from that point, then I get to the center of the x-axis. And if I go 540 pixels positively down, then I get to the center vertical point of my camera's view. CC Particle World normalizes that value so that the center of the world is a value of 0, 0 on the X and Y axes. So we basically have to convert this position value from After Effects to the positioning value of CC Particle World. And while it is a little bit of expressions work, you can just copy and paste the expressions from the description of this video if you want. But I'm gonna walk you through exactly what's happening. Let's start with position X and add in an expression by Alt-Option clicking on that property. And the first thing I'm gonna do is use the expression pick whip to select the X position value of my emitter null. So that fills in the code that I need to reference that property. But it is a little bit long and hard to read, so I'm gonna simplify it by turning it into a variable by typing VAR at the beginning and naming this variable. We'll just call it P for position, and then put an equal sign between that P and the actual line of code. Now remember, the origin of the comp is the top left corner, but the origin of the effect is right in the center. So that's half of the comp's width, and that's actually how this position system is measuring. The width of the comp is normalized to a value of 1. So instead of this comp being 1920 pixels wide, CC Particle World is saying the width is equal to a value of 1. 0.5 in this direction, negative 0.5 in this direction. So what I need to do is subtract half of the width of the comp, which is the distance between the edge of the comp and where the producer actually is, from this X position. And to do that, I'm just going to add in minus this comp with a capital C dot width divided by 2. So we're taking the comp's width and dividing it by 2, giving us a value equal to half the width of the comp, and subtracting that value from the position property. I'll finish all of that off with a semicolon, and I've defined that all as a variable. So now I can drop down a couple lines and actually write my expression. And I'll start by calling that variable just by typing the letter P. And now After Effects is going to interpret that P as all of this code that we just typed up here. And I want to take that value and divide it by this comp, again with a capital C, dot width. So we're again dividing everything by the comp's width. And the reason we're doing this is, remember, because we're basically taking that 1920 comp width value and converting it to a value of 1 in CC Particle World. So if we divide this value, which is calculated right here, by the comp's width of 1920, we're essentially converting the units of this position data to the units of the CC Particle World position data. So if I click off and now scrub through, the emitter's X position is going to move around with that null object, no matter where it goes. But we still have the Y and Z to deal with. So all I need to do is copy this expression, go into the Y position and add an expression there, paste it in, and then modify it just slightly. We need to go into this variable, and instead of targeting the first value of the position array, which is the X position, we need to increase this value by 1 so that we're targeting the next position value in that array, which is Y, the Y axis. We also need to change this little bit of the expression where we're subtracting the comp's width and instead subtract the comp's height and divide it by 2. Everything else can stay the same. If I click off, now that Y position is going to be linked to the Y position of the emitter null. Now, even though I don't have any Z position animated yet, if I added some in right here, the actual emitter is not going to be linked to it anymore. So obviously we need to add that in, and I'll double click on the position Z property to bring that up, and then add another expression. Alt or Option click on that Z, paste in what we already had, scale this up a little bit so I can see it more, and change this to a value of 2. So we're not targeting 0, which is the X, or 1, which is the Y, but 2, which is the Z position of our null object. And we can actually take off the rest of that expression because both After Effects and CC Particle World use the same origin point for the Z axis. A value of 0 on each is identical, so I don't have to subtract anything from that value, but we do still have to divide it by this comp's width because that is what determines the scale and change of units between the position of After Effects and the position of this effect. I'll click off, and that emitter immediately snaps to the position of my null, and I can play this back, and the emitter will be with that null no matter what. Now that was a lot of work trying to explain something pretty complicated. I hope I didn't lose you, but like I said, you don't really have to remember any of that. You can just save the expression or come back to this video and copy and paste it from the description. But now that this is all linked up, we can actually look at the rest of these controls. So let me collapse my grids and guides and move on to the other settings. So we have the radius X, radius Y, and addition of radius Z. So that's the only difference between this and Particle Systems 2. I'm going to drop all this down to 0.2, so it's a much smaller producer. I also want to turn off all of those guides. Sometimes it seems like those just pop on randomly, so I'll just be turning them off as they come up. That's it for the producer category. Let's move on to physics. This is nearly identical to CC Particle Systems 2. We have all the same animation types, so I could change this to jet sideways and we're going to get particles shooting out based on the motion, but it's also going to work on the Z axis. So if I pull this one out and I maybe shoot this one back, it all works in 3D space. And I can even have a camera flying around this if I wanted to. But we have all of the same physics controls: velocity, inherent velocity, gravity, resistance, extra, and an addition of extra angle. And this is an added control because of the third axis that we have access to now. And that third axis actually gives us some extra animation controls too. So we have direction axis as opposed to just direction in CC Particle Systems 2. So this extra angle control allows us to rotate that direction in 3D rather than just around in 2D like on a clock face. The extra property again controls the spread of those particles, but extra angle actually rotates that around. Now we also have cone axis, which is going to spit these particles out in more of a cone shape. Again, turning down the extra is going to narrow that cone, and the extra angle controls the fan of that cone. And if I were to turn my gravity down to 0, it would make it more apparent what exactly is happening. So let me go to a point where the emitter's not moving around and adjust the extra angle. So you can see how it's kind of fanning it straight outwards at a value of around 270 degrees. If I increase it further, it's going to fan it upwards and bring it narrower and narrower, or towards 0, it's going to narrow downwards. Let's take a look at the other animation controls that are a little bit different, like viscous. And according to the actual user guide, this animation type is actually obsolete. It's only there to be supported by previous versions, so you really don't need to use that one. It's very similar to explosive, but has less controls. There are 2 more options down at the bottom that are unique to CC Particle World, Fractal Omni and Fractal Uni. So let's start with Fractal Omni. And again, this looks very similar to just the standard explosive, but it is again less uniform than explosive, just like in CC Particle Systems 2 with the Fractal Explosive animation type. The extra value will adjust that fractal, but as you can see, it's actually 3D fractals. It's changing the velocity of all of those particles using fractal noise. And the extra angle just changes the shape of that fractal. Now, Fractal Uni puts out these particles more uniformly. Instead of going in every direction, they're going out in one direction. So if you were trying to make an explosion that was coming out of a single point, then we could use this type and just keyframe the birth rate. So if I set this to a value of 0 and set a keyframe, and then go forward a frame and set it to a value of maybe 10, and then go forward 2 or 3 frames and set it back down to 0, then we're just going to get this burst of sparks. And you can play around with the physics to make this look however you want. All right, let me undo back before I added those keyframes, and then take a look at these next 3 options. There's floor, direction axis, and gravity vector. Now, I'm actually going to skip over floor for a second and go straight to direction axis because it directly applies to this animation type. Now, once again, this guide has popped up and it is interactive. If I click and drag it, I can rotate it around within the comp and you can see what's happening. It's basically showing me what direction this Fractal Uni emitter is facing. So if you want to rotate it around that way, that's fine. Otherwise, you can use these sliders right down here. But using these controls, you can specifically point this emitter to fire out these particles wherever you want them to be. And these direction axis controls are only going to show up on certain animation types. If I go to explosive, they're grayed out, or Fractal Omni, again, they're grayed out. It's only for animation types that actually have directional properties. All right, I'm going to change this back to explosive, and we'll take a look at gravity vector next. This is literally just the direction of the gravity. So if I reset that gravity value to its default of 0.5 and go to a point where the producer is still, in fact, I'll move the producer up further for its final position so we can see it higher up. The gravity vector determines what direction the gravity actually pulls in. So if I change this 1 to a -1, it will be reversed, but it's not actually the amount of gravity, it's just the direction of the gravity. So changing this from 0 to 1 has no effect on the speed of that gravity, it's just the direction. So if I increase gravity X or Z into anything besides 0, then it's going to influence the gravity overall, but it's combining it with the gravity Y, which is set to 1, it's a maximum. So if I increase the X gradually, then it's going to go in an angle towards the right side, value of 1, it's going to go at a 45 because both the Y and X are equally pulling it. If I turn that Y gravity down to 0, now the gravity is going straight to the right. So playing with these values at less than a value of 1 will shape the direction that the gravity is pulling the particles. But I'm going to just leave these all at their default so that gravity falls downwards. Now let's go back up to the floor category. And to make this a little bit easier to see, I'm actually going to enable my grid and turn it onto the floor so we can see it. Let's turn that grid size up so we can see that nice and clearly, and these particles are just falling straight through the floor. But if I go into my floor options, I can adjust the floor position to be higher or lower, but I can also change my floor action from none to ice, glue, or bounce. So let's start with bounce. Immediately, my particle simulation is changed. What's happening is the particles are hitting that invisible ground plane and then bouncing up. So let's bring that floor position up a little bit. And I'm actually going to change my particle type from line to motion polygon so we can see the direction of these particles. So they're being emitted out, flying down, hitting the ground, and bouncing again. And we have properties to control this bounciness. So I could make them more bouncy, and now they're gonna bounce higher. I could turn that way down and they'll bounce far less. I could turn up the randomness of the bouncing, and I could turn up the bounce spread, which just randomizes the direction that they go after bouncing off of the floor. So if I turn it all the way down, they're all going to just uniformly bounce around. If I turn it up, it'll be much more chaotic. Now up above the floor action, we have render animation, and it's set to normal, but we could change this to reflected on floor, and it's basically giving us a reflection of our particle simulation. So if you needed to have this particle simulation reflected, this is a way to actually get a 3D version of it mirrored and reflected off of that floor surface. I could also change this to projected on floor, which would allow you to basically generate shadows from this particle emitter that are actually accurate. Now I want to leave that back to normal, and then take a look at the properties above it, which is particle visibility. It's currently set to all, but I could change this to render only the particles that are above the floor. So as soon as they cross that floor threshold, they disappear. Or I could change this to after floor, and we're only going to get the particles that are bouncing. And these are all ways to be able to separate parts of your particle simulation so that you can treat them differently or composite them differently if you need to. I'm gonna change that back to all, and we'll take a look at another floor action. So let's say ice. Like you might imagine, this is going to have the particles hit the floor and then slide as if it's on ice. But we don't have any other controls for that floor action. Next is glue, and this is going to be like darts sticking into the ground. The particles hit the surface and then fade off. And this is a little hard to see because we're using the motion polygon particle type. So as soon as they stop moving, they get very small. But if I change this to just try polygon, then they're gonna hit the floor and stick there. So those are the 3 different floor actions. I'm gonna change this back to none so it falls through again. And that finishes up the physics category. Let's move on to the particle section where we have a few different controls than CC Particle Systems 2. Let's go back to the first particle type, which is line. This grays out a lot of controls, but almost everything else is identical to Particle Systems 2. We have the max opacity, the color map, birth and death colors, and transfer mode. The additional controls we have are the opacity map is no longer just a couple of presets. We actually have this map that we can draw on and manipulate. So this graph is representing that at the start of the animation, it should be transparent, and as time goes on, it will get more and more opaque, stay opaque, and then gradually fade off into nothing again. But I could change this just by clicking and dragging with this pen shape and curve this out to be whatever shape I want. I could even go up and down a few times before the end. And if I turn the particle longevity down a little bit, we'll get rid of that grid. And then I'll jump into the physics and turn the velocity all the way down, turn the inherent velocity down, and just let gravity pull it downwards. I'll reset some of these other values as well. And then finally change it from line back to, say, try polygon so we can see it nice and clearly. I'll zoom in here and play it back. And what our opacity map is doing is shaping the opacity of these particles over time. So if I do a bunch of up and down movements, we're basically going to make our particles flicker. Let me turn up the longevity just a little bit more so you can really see those opacity changes. So at the start, it gradually gets up, but I could modify this to have it just be 100% opaque at the start. I could really go crazy going up and down and up and down and up and down. And now throughout the life of the particles, they'll basically be increasing and decreasing their opacity until they disappear. Now, obviously, I don't like the way that looks. I'm just gonna change this back to a nice smooth curve. Now, obviously, my smoothness is nowhere near as smooth as the original, but if I hold down the control key and click and drag to the right, it's going to smooth it out. So I can keep clicking and dragging to really smooth this out. And to make this a little bit more dramatic, I'm just gonna go really fast and bumpy and show you that clicking and dragging to the right will smooth out your curves a lot more, so there's not such drastic bumps. You can also hold down Shift and click, and it will raise the highest point in your graph to the top point of the opacity map. I'll close that up and move down to custom color map, which is a more complex way of applying colors. Instead of just using birth color and death color, I can change that color map to be custom. And now we not only have birth and death colors, but also 25, 50, and 75% colors. So I could change these colors to absolutely anything I want, and they will just cycle through the life of the particles. So it's just an added level of control to be able to stylize your particles however you want. Now, this next option called Volume Shade Approximate only shows up for certain particle types, but on these triangles, it does work. So if I increase volume shade, what it's going to do is basically shade the particles based on how close or far away from the camera they are to give them more depth. So if I increase the amount of particles and maybe make that producer just a little bit larger, and then modify that volume shade again, you can see how it's making the closer particles brighter and the further away particles dimmer. Now let's back up a few controls and take a look at the rotation speed and initial rotation. These are basically just better labeled controls for what the extra and direction properties did in CC Particle Systems 2. On the tri-polygon particle type, extra and extra angle are going to affect the animation type, and rotation speed and initial rotation is going to affect the particle type. So if I turn the rotation speed to 0, then the particles are not going to rotate at all as they're emitted. Let me turn down the birth rate so we can see them a little bit more individually, and I'll zoom in nice and close here. The initial rotation value is actually a randomness. So if I turn it all the way down to 0, then my triangles are all going to be pointing upwards, and because I have no rotation speed, they won't rotate at all. If I increase the rotation speed, then they're going to start at an initial rotation of nothing, and then eventually start rotating. Then we have the option to control the rotation axis. It's currently set to any axis, but I could rotate it only on the x-axis. And let's just turn up that rotation speed a bit so you can see that they're kind of flipping. I could change that to y-axis, and then they're going to be rotating around. Or the z-axis, and they'll be rotating more like around a clock. I'll set that back to any axis and increase the initial rotation so it's a little bit more random again. We have a size variation slider, which does exactly what you think. It's a randomness control. Now let's jump back up to this texture section, and this is another unique property to CC Particle World. If I change the particle type to something that uses a texture, like a textured quad polygon, instead of pulling the texture from the layer we've applied this to, we can now choose a texture layer. So I've created this little smoky element that's not very big at all. It's just 20 pixels by 20 pixels. And if I pull that pre-comp out into this comp, I don't even need to see it, I'll just turn it off. I can select that as my texture layer, and my quad polygons are going to be textured with that pre-comp. Now I'm going to change the transfer mode to screen, so this looks a little bit more like smoke, and then come back up here and take a look at the other controls. We have this scatter property, which allows us to shift the texture around within that quad polygon, but once it fills the edges, we're really going to see that show up. So I'm not going to change that. Next, we have texture time, which is set to current, meaning that it's sampling the current time in the comp for the texture that we're applying. So if this was animated, and in fact, I will animate it just by going into the evolution and setting some keyframes and increasing this value. So now the animation plays back like this. My particle's texture is going to be animated as well. But I could change this from current time to birth, and then it will take whatever point in time the particles are generated at and sample that point in time's texture and freeze it at that point throughout the entire simulation. Or I could change it to from start, meaning it's going to align the start of this pre-comp texture source to the birth time of every particle. So each particle will play through that comp from start to finish. These are very, very powerful controls. Now we also have this grayed out box that says align to direction. This is only going to work with particle types that have direction properties, which again is unique to CC Particle World. If we go to the particle type, we have this section at the bottom called textured square, textured disk, and textured faded disk. So if I change this to textured square, then not only are we no longer going to see those hard edges, we're going to get the coloring controls back from our custom color map that we set up. So this last section of particle types is very powerful because now we're sampling this pre-comp as our texture. It's blending it better because of the way that it's applying the texture to the particles, and we're still able to color it using our color map. And this also applies to the textured disk and textured faded disk as well. But with textured disk and faded disk, we also have the ability to align to direction. So let me change this to current for the particle texture time, which will rotate the particles based on their motions. So if I change the physics velocity to be much higher, then the texture is going to face the direction that those particles are traveling in. So you see how this particle right here is pointed kind of this direction. This one right here is pointed this direction. And that applies to both textured disk and textured faded disk. And at this point, so many of these little properties and names carry over that it's pretty self-explanatory as to what they mean. Once you start getting in here and playing with these properties, things start to click and it starts to make a lot more sense. I know it's a lot to look at first, but getting your hands dirty and actually playing around with these controls and reading the user manual is how you can really get a good understanding. Now let's take a look at the extras category and jump right into the first one, which is effect camera. The effect camera is the 3D camera that this effect is actually generating. Lots of effects have this system where you can choose between an effect generated camera or the comps camera to drive the 3D scene. The thing about Particle World in particular is that none of these controls will work if there's any 3D layer in your scene. Even if you don't have a 3D camera, I do have a 3D null, so adjusting these properties will do absolutely nothing. Now, obviously I don't want to get rid of this control, but just to show you how it works, I'm going to delete it. And now these controls will allow me to rotate the effect camera around. I can move it in and out, and I can even change the field of view. But these are all controls that you have access to just by making a 3D camera. So if I add another camera back in, I can rotate it around, I can move up and down, dolly in and out, and I can even zoom in and out under the camera options to change the field of view. Okay, I'm gonna get rid of that camera. That's all for the effect camera controls. And next up is depth Q. And this controls the visibility of the particles based on the distance from the camera. So by default, it's set to none, meaning the particles are not influenced at all by that depth. But if I change this to fade, then the further away they are, the dimmer they'll become. So if I make my producer much bigger on the Z axis and I rotate my camera around to be facing those, you can see that the particles closer to the camera are brighter than the particles that are further away. And I can control that fall off with this distance slider. So if I turn it down, then they're going to fade out much sooner. Or if I can crank it up, then they will fade out further away from the camera. The next option is fog, and this basically tints the particles to whatever you set the fog color to, again using this distance slider as the control. So if I wanted to fade them all to, say, black, I could just set black and they'll fade out to black. Or if I want them to fade to white, I'll make them white. But that's all for depth Q. I'll set that back to none, and then we'll go into the light direction. Now, this effect does not actually react to lights. So if I add in a point light and set it to 100% intensity and click OK, that's not going to affect the particles at all. No matter where I move it in my scene, it's not interacting with these particles. But we do have the light direction controls within the effect. So I can rotate my light source around, which interacts with the particles and how they're overlapping. But that's the extent of those controls. I'll collapse that. And the next option is hold particle release. So I'm actually going to get rid of my 3D camera. We don't need to be looking through that anymore. And I'm going to turn the radius back down. And this is basically a delay for the start of the particle simulation. So let me just move these keyframes out of the way so we're static at the beginning. What this basically does is holds the particle in place by a percentage of the particle's life. So the particles will appear before then being emitted from the producer. So if I set this to 75%, then 75% of its life is going to be spent right where it's birthed, and then the animation type will be applied to it and it will go out. And if I change this to 25%, it'll get released quicker. Next up, we have composite with original, which just composites those particles on top of whatever the layer was before you applied the effect. As a white solid, it's very hard to see those particles. I'm just gonna uncheck that. And then finally, we have the random seed, which just randomizes the simulation. And with that, we have covered every single property, control, and menu inside of CC Particle World. Hey, thanks for watching. If you enjoyed this tutorial, then check out the other ones here on my YouTube channel. And if you like my teaching style, then definitely check out my longer form content on Skillshare and School of Motion. And if you want to support more tutorials like this one, check out my Patreon. You can find links for all of that stuff in the description of this video.